camera's off. 2 seconds, everyone. Be right back. Watch this. Be right back. Hey. There we go. Fix the camera. Got the camera. Well, how is everyone doing? Let's see who's all here. We got the camera back. Let's see. It is office hours. It is the week before spring break. Just lots of time right here. Office hours. So many Pokemon. What is everyone doing? How is everyone doing? We'll see who swings by today, but it's a really chill day right now. Might do. You know what we might do? We'll see who all shows up. But we could actually do the activity for BAS 320. Let's go take a look right here. I'm going to get that loaded up. And we could start looking at that. Quizzes. Ooh, there it is. That quiz is open for a while. That is a long time for Simple Linear Regression Part 2 quiz. Well, let's take a look at it. Let's see. Hey, Brianna, how are you doing, Brianna? Do you have any questions? I was going to pull up the Simple Linear Regression activity, and it's funny because we're doing that in 201. So whatever you're wondering about, let me know. We can take a look at it. Because we've got a lot of work. Let's see right here. 4 minutes and 10 seconds. Activity, Simple Linear Regression. BAS 320. And let's take a look. No questions right now. Awesome. Let's take a look at some regression. You're going to get to see some cool stuff right here. And let's go take a look at some regression. Here we go. Okay, so this is Simple Linear Regression Part 2, which breaks into some more advanced stuff. So if you're in 201, you get to see some regression right here, and you get to see it at a pretty interesting way of doing it. So use the data command to load in the bulldozer data set. This contains information on 924 bulldozers, because that's what we're all interested in, that were sold during an auction. We want to predict the selling price, which is the Y variable of interest, the sale price, from its year made. You can read more about the data bulldozer by doing $bulldozer. And we need to have reg class loaded up, which it looks like we don't. Library reg class. There we go right there. And now we could read more about the bulldozer data set. And here's the bulldozer data set information. And cool, selling prices of bulldozers, all that great stuff. And now let's go ahead and take a look at a model, linear model, predicting the sale price. We're just going to copy paste that. Explained by, this is the X variable, and data equals bulldozer. Oh, we didn't load in the bulldozer data. There we go. And there we go. Let's make sure we understand what this format is. This is the y tilde x comma data equals, and the data is named a data frame. So you see the name of the data frame is bulldozer, the x variable is year made, and the y variable is sale price. LM stands for linear model. We're going to fit a line, and M is the object we're storing this into. So everything right here on the right side will be stored into this. It's going to create that object M, as you see right there when we run the code. So we use an object M to manipulate it. Probably it would work if I did this right here. So you might say, well, why are we doing M? I believe this will work, but the M is the same thing as this. So saving it as M is going to be the same thing as having the full linear model. So we're basically creating a shorthand for it. We're saying, okay, this right here is going to be saved into this object M, and this object M is now this whole linear model we're creating. Now we can look at everything for that linear model by saying, what is a summary of the linear model? What is the visualization of the linear model? And all this good stuff. Now, if you were in 201 today, you got to learn the conditions of QQ straight enough, no outliers, plot doesn't thicken. And let's take a look right here at the conditions. QQ straight enough, no outliers, plot doesn't thicken. And you might be wondering, well, are there issues with this correlate or this regression right here, which is based on correlation? Does anyone, if you're watching right now, see any issues with this regression? I should mention this as 201 320. So 201 stat 201 /BAS320 regression review. So with this right here, we're just reviewing regression right now, talking about it, and I see some major issues with this. And I'm wondering, I might Google something really quick right here. So I see major issues with this regression. Wonder if anyone else sees it, because this has problems. And it's right inside of here. Probably the easiest way to see the problems is using a code we'll learn later on called choose order. And we're right here. There is some thickening too. Brianna, 100 points. Great. Brianna, 500 points. Brianna, thank you for hanging out right here. There is some plot thickening. I'm throwing 500 points, Brianna, right there. I do see some plot thickening issues. I see some linearity. So I see a linear problem and I see a plot thickening. So Brianna, you're probably right. There is a little bit of plot thickening through here where it maybe is getting a little bit thicker throughout. So probably some plot thickening. Also, the linearity issue is a pretty big issue. It's not really following the straight line pretty well. It should bend. So usually we just have it draw the linear model for us. Here's what the linear model looks like. And I do see, like you're saying, a plot thickening where it's a little thinner here and it gets thicker across. I'm going to try Googling something really fast over here to see ggplot, visualize regression model. I'm going to see if anyone's made ggpredict, visualize multiple regression models. Ooh, ggpredict. What function? This is ggpredict, ggextra. Okay, dev tools. We got to do this. Let's install a random thing that I've never used before. Skipping install has not changed since install. Wait, do I have it? Ggpredict. No, I don't. It's the GG graph extra. Okay, looks like it's got it. And then ggpredict. Okay, that's all right. This is a function someone made right here to do the regression. What's probably pretty nice about this is we could also do a plotly of it. So let's look at this and pipe it through a ggplotly. And we could probably do it. No, it doesn't. Ooh, and I don't like his code or their code. I don't know who made this. But you can't ggplotly it, which is kind of a bummer to me, which would be the main point I'd love to use with this. So I'm not really liking their code right there because I can't do the things I want. I also don't like that it doesn't have a color for it. Let me look at the ggpredict code right here real quick. There it is right here. Fit, color n, point, jitter, standard error. So it's got a bunch of true false things, standard error. We could do standard error. Let's get that. SE equals true. There's the standard error of the line. What else were there additional arguments? Color is factor, digits, interactive. Point, null, jitter. Oh, show summary. That's cool. Let's try that. Wait, what did that change? I am not seeing a change. Well, I'm not loving their code. It's an all right code, but I've seen codes that do way more and do better things. I mean, it's okay. I didn't write it, so I shouldn't complain, right? Wait, did that show the summary when we run it? Oh, it just shows it there. Well, that's cool. This is going to be better right here. I just like making cool graphics if you can't tell. This is a long way of doing it. And then they're showing the ggpredict, which... Ooh, wait. Oh, no, wait. Oh, wait. What is this? ggpredict, fit, interactive, true. Okay, wait. So they have it. There we go. Okay, this is what I wanted. Okay, now this is way better. This is a plot that I would actually like, and I actually want to create the visual of, if it makes properly. And we should be able to hover over it, and we can see the information for that point. So you could even zoom in on points, or can you not? Or you can just hover over them. That's still pretty good. The main point being with this is we could take and let's remove this right here. I want to remove our install packages. Let's remove our extra code. And I'm wondering, let's check a few things. So I might show this in class. So I'm kind of doing some exploration of new code myself because I bet you, well, first off, we can probably knit this to HTML and it'll work. It's probably going to work when I knit to HTML. The answer looks to be yes. And we have now created an interactive regression model right here where you could hover over the points and you could see that that values that. I wish it kind of dimmed the points a little bit more. It's a little hard to see with what the values are, but you can see that is 0.287. That's like in the data, like that was observation 287. It has a year made of 1965 and the bulldozer cost $12,000. It might make more sense if I go back here and I change it to like a height weight data set. So let's do survey 10, not survey 11. We'll go here to predict somebody's height from their weight. And we'll use survey 11. We didn't load up survey 10 yet. Why am I saying survey 11? And there's survey 10. And then let's go ahead and knit it again. And we're going to see a similar thing. So what's neat about this is getting the interactive plots. And I might be able to add a title to that, probably. I like to talk about in, so we can see that that person's pretty odd right there. I wonder if I can dim the points a little bit. I wonder. Now, there should be in the GG predict. Not GG. There we go. GG predict. Should be like a point thing to dim the points. Let's take a look at that. Show interactive true, color, numbers to color variables, point, lather will not show the points. So we need that. Digits, interactive. And so I wonder if they are, there's no way I can just write color in here and it'll work. It's not gonna like that. No, it doesn't like that. It didn't break it, but it didn't like it. Just didn't do anything with it. Let me do this. Sometimes you need to edit someone's function. Here it is. Wow, that's a function. This is a cool function. So this is the function they're doing right here to make the plot. And so I'm basically going to try to take this function right now and manipulate it to get exactly what I want. And come on. There we go. Okay, so we're going to store into ggpredict2. There's the function. There's the memory allocations and all that stuff. There's where it returns the graph at the end. All this good stuff. There's the hover. So that's how he's doing. Oh, there's great stuff. CSS, nice code. But I wish he had the ability to change the plot. So we need to find that. Where there's his geom point. Geom point interactive. I've never even used that. Geom point interactive. If else. Okay. If jitter. So there's where he turns on the jitter. If point jitter. If colors factor. Column facet. So let me look for those geom point parts. There's the geom point. That's the interactive data. Geom point interactive. I feel like that's what we want. He's adding to it. He's taking his graphic and he's adding because his graphic's P. Or I don't know who they are, but let's see. A bunch of code I haven't seen before. I don't know the giraffe. So that's interesting. Using lists, it looks like. Surely, there's the model. Okay. GLM, if LM. Okay, he's choosing between the models on how to do it. He's making the equation, figuring out all this stuff right here. Okay, a lot of it's only the graphing at the end, it looks like. And where does he first? Here it is right here. Here's where he first starts creating the graphic. He stores into P, ggplot, data equals new data 2. I keep saying he, but y equals y name, x next name, group. Okay, so right here, cool. Okay, now we have a ggplot2 thing. Let's see if we broke it. And 2. Could not find function. I hate it. Sometimes I don't know how people do this. I don't know how they have functions that I don't have. Like geom point. There are things I don't know, and I've seen this with like beepr, where a function uses things that I don't have, and I don't understand that. Let me Google this in the background because I am utterly confused on how someone can use something I don't have. I need to talk to someone and be like, how does this exist? It's in GG. There it is. It's in this giraffe. Oh, I know why. I bet you. No? Well, I'll be. I have no clue. I have no clue. Object gray not found. Okay, cool. We broke it in a good way this time. It's broken in a good way. So now that it's broken in a good way, because I wanted it to break that way if it was going to break, we need to go to where I put the gray in. There it is right there. So probably because it doesn't like that. Else, so did run that, stored into P. Geom ribbon, okay, with the standard error. So it's just standard error ribbons being created right there. If point is jitter, these are the points is where we need to go. And there's the geom jitter. So I wonder if interactive points cannot be changed. Geom point interactive. Okay. Oh, might not have a color ability. No, color can be something. Okay. Good. Okay, that might do it. Okay, now we got gray. We've done it. It's a little bit easier to see. All this work to get it easier to see. It's like I wish the text was a little bit bigger on the interactive points. I'm wondering if let's see how it looks now. Is it gonna does it change all those? Wait. Oh, haha. What does it? Okay. That's a little bit better, I think. Could have an alpha. See if this works. It doesn't like that. I mean, it's a plus alpha. I don't usually use that. Yeah, so I thought it didn't like that. It's not usually what I do. I haven't used the alpha. Well, you know what? Let's go to the alpha real quick because I haven't used that code much. Modifying color transparency. Oh, wait, here we go. Objects exported for other packages. ggplot alpha. Wait, geom point. There it is right there. There's the alpha. But maybe it's right here. Here, right there it is right there. Oh, we got a bot. There we go. So is it... Oh, so that's that. So it's color equals... Okay. So what we need to do is we need to go here to color equals alpha. And then we go here. I didn't know this. Okay, so hashtag FF8200 and then alpha level equals 0.4. That's interesting. Well, the more you know. Now that should do it. That should change the alpha level. Looks pretty good. Let's go much lighter alpha. So the alpha is the transparency of a point. And so we're just working towards, there we go, right there is that. So it's a little bit harder to see the points, but I don't like how it changes the, it shouldn't be, it should auto size. Oh, I've never done that. Wow, that's interesting. I like clicking every button if you can't tell. Pretty good. I'd say that works. Oh, because of the cluster of the points, that's why points are showing up so much. That's all right. Let's go here to 4. And let's go here to the top. And let's go here and say color equals, or let's say point color. Point color equals orange. Point alpha equals 0.4, comma. There we go. I think that'll do it. And then we want to say point color and point, okay. Point color, point alpha. Okay, that should work. And it's working. And so now we have that function created for us. So all this work to create a function right here. And you know what it's missing? Let me see if this will do. Because we can probably take and go to plus GG title on this and say, I guess, yeah, hello. And it doesn't like that. That's interesting. It really doesn't, well, might have to do a facet plot or something to get a title on top of that, which is kind of a bummer. We do have our axis titles, but it works for the time being. And now we can go here to point color equals red, and point alpha. All this work right here. But this gets us the function we want. Gets us the interactive, and then we'll try some additional stuff right here. And point alpha equals 0.7. So now we should be able to change it. There we go. And I see that's the problem. It's got to lower the alpha a little bit to see it pretty well. And now we can actually kind of see what's going on right there. If we hover over points, and we can see the different things. Let's go to height and weight now. And here's our height weight model. And we can see the relationships between people's heights and their weights. So pretty decent right there, and we can see, and that's the goal of it. So let's go ahead and knit this to HTML again. See how it looks inside of here. All this, could not find function with this right here. Yes, because I created a user-defined function. That's why. So now we need to go into our thing right here. We need to insert a chunk. Insert chunk of our code. We're going to go here to the chunk settings. We are going to show nothing but run the code. And then we are going to collapse this. We're doing a lot of fun coding today. We're going to take all of this right here and collapse it in. And there we go. Now it's collapsed, so we don't have to look through it. We could call this like create create regression plot 2. And so that is create regression plot 2 right there. Did I not name the chunk properly? I think everything's fine. Does it need a comma after that? And then comma right there. There we go. Create regression plot 2. There we go. Everything's good. I don't usually name my chunks all the time, especially with long names like that. And everything looks to be good. It likes it. We're going to reknit it. And right here we go. Arrow at geom point. Could not find function geom point interactive. That's because, That is because of this library right here. It's shown after, and so that library needs to go there. Don't put your code after that needs to run. And so now, third time's a charm. We're going to try knitting it now. And we're going to get, here we go. We got it. We got our interactive plot we were looking for. And this is what we wanted, is a plot like this to see the points and talk about individuals and just hover over them. Really easy to see what's going on. I wish it also calculated the residual. You know what? I feel like we could calculate the residual. Like I like doing tasks like this. I like to, be like, could we calculate the residual and actually have it show the residual? So we need to look at that geom interacted point, because right now it's showing us the XY value, but we need to calculate the residual. So to calculate a residual, it would be the distance that a point is away from the line. So it's currently showing the equation of the line if we hover over the line, but you would need to plug in. I also don't like that it doesn't plug in the variable. It should give you your Y and X variable when you hover over it. Like, I don't know why people don't say like, hey, let's go the additional mile right here. Let's plug in your X and Y variable. So I like that it goes red now. It's kind of neat from us coloring it red, but we can change the color to green or whatever we want. And also, I don't think it'll knit to Word. I think it'll have problems. Or maybe it'll be smart enough. It's doing it. Execution halted. So we have to turn off the interactive true, because it did stop it. It said, nope, can't do that. So now we're able to knit to Word. We should have everything work fine right here. We'll get it loaded up. We'll take a look at what we get. And we do get the plot. We don't get the interactive capabilities, but we do get a pretty decent looking regression plot. We can change the colors of it, but pretty nice regression plot. Color it what we want, make it look how we want to make it look, but pretty nice looking regression plot. The green, maybe not so much. You could go purple and make it not so alpha. And let's knit. You know what? How many points did I say I said? What is it not like? Alpha's missing. Okay. If this works, this will make my day. Please work. Please. Oh, is it? Oh. I might be mad because this is already created. I love it. Oh my gosh. I'll send Petrie this and say, like, here's your new regression plot. Just complete funfetti. In the theme of funfetti, we've done it. We've created a rainbow regression plot. I do wonder with the interactive true on this, if with the interactive true, it would change the color of the line. It's red, it's red, it's red. Okay, it's red everywhere. But I would not suggest this. This is just kind of fun. Funfetti. Is it going to do the same color point each time? That one's purple. Purple. Yeah, it looks like it's the same. Make it less. What happens if I go here to 10? Oh, it's mad. That's why I did 699, because there's 699 points, and it needs 699 colors to assign those points to 699 values. So we got it to work right there. So pretty neat, pretty fun with that. We're going to try to get the plot to show up here with the value. And once again, we turn down the alpha so we can actually see things. Makes it a little bit easier to read output. Maybe to a 0.2. You see at that point where it goes to like too dim. So maybe I'm going to go to that. It's like you got to get things exactly the way you want them. So you can see things. It's just hard with the points being so close. I wish it kind of made the box. Maybe we could make the box that it appears in. But I think that's the geom point interactive. So we need to start looking at that code. Okay. That's the main theme right here. Is the geom point interactive is something we're going to have to manipulate and work with right here. To go to the geom point interactive as string data ID tool type. Okay. This is an interesting thing. Geom point interactive. Let's take a look at it. Oh no, it's got that thing where you can't look at it. Oh, we might be stuck on this. We might be stuck on this. Arguments with the mapping of the aesthetic. Okay, so it's mapping our aesthetic on there. In this way, they can be mapped to the data columns and apply to a set of geometries. Let's plain arguments for the Here we go. They're showing how they use it right here. Geom point interactive. Okay. Data set not found. So they created a data set right here. Well, this is a rather not so interesting display. And that's in 710. So it has the, it doesn't show everything. It's showing, I feel like this is not the full plot. That is not nice code. Let's make this look a little bit better right here. Whoa. Okay, there we go. This looks better now. I've never done structure list. That's interesting code. Okay, so they're outside of that. This code came in really not pretty. Oh, they just made a data frame. Wow. Okay, so they're doing, that is such a long way to make a data frame. And they're taking 6 observations and they're making a ggplot of the data set. Geom point interactive, x is equal to the weight, y is equal to the qsec, and colors the display, whatever that is. Tool equals car name, that equals theme minimum. Okay, let's remove the theme off this. And then let's take a look. So there's the object, there's the 6 points. And then they are using the giraffe thing. Creates an interactive graphic with a ggplot object to be used in a web browser. This function should replace function ggiraffe. Okay, so this is, you take right here, and they just have it. They don't even need to probably pull this. Well, there's the. Okay, so there is the. You name the gg object equal to this. Okay, so that's where their gg object is. That's their gg object, and it turns it into a web-based interactive object. And then if interactive, print x. So we should just, okay, there it is right there. Now that is the Hornet 4 drive, but that's the name of the car right there. So we're only seeing tool type, car name. There it is. Okay, so that's how that's being displayed. It's the tool type. So we need to, under tool type, under the geom point interactive, the tool type is how we get it. Okay, so the geom point interactive, geom line interactive, geom point interactive, tool type. And they did tool type. Oh, do they have a tool type here elsewhere? There's tool type. So they're creating this right here. They're getting right here the information on it. Okay, if color name, that's a bunch of other stuff. We're not doing those yet. Let me find tool type. No, but they're doing name equals to type. That's the word tool type. Tool type equals tool type. Okay, well, here's where they're doing the background color. Background color white, font style italic, padding, border, radius. Let's try this. Watch this. No, but it's white. Hover, white keystroke. Fill. Selected CSS, fill. FF, what is this in? This is hexadecimal color code. And that might be a light fill. That might be where we're seeing it. So where is, I'm trying to find out what this hexadecimal color code is. Oh, that's the line. That's where the line is being created. So that's the line they're creating right there. And we're talking about, do we have it in the viewer elsewhere? I think we have it earlier. So that is the color right there I think we're seeing. And then it's black if elsewise. We could confirm this by going here and saying something like orange for this. Probably that should work, or FF8200. I should have noticed that was like a higher, closer number. And so we should see now is we should see an orange line when we don't click on it. If I've changed the right thing. No, I'm wrong about it. Okay, well, I was wrong. Let's try it on this then, because I thought it was this. Let's see right here. No, I'm not changing what I thought I'm changing. And it's weird it's grabbing that point right there. Something is not happy, it seems. Okay, so that is not changing what I thought it's changing, which is never good when we don't know what we're changing. So hover 4 pixels, cursor, point, stroke red, stroke width, background color white. I think I know what this changes. I think it's going to change the back. Yep, there it goes. We can't see anything. Try and change the alpha on that, though. I want it so it doesn't... So we are manipulating that right there. You know what might be interesting? Can we not... Let me look at this. I don't think that's just an object. Let me try to change the font to white. Okay. Background color. So I'm literally looking up like CSS code right here, which is always good. So background color, that color, this might be it right here. Okay. Let's see if this helps. And then we have to do another. No, this. Okay, that might do it. I don't usually do this type of coding. This is not my coding. Oops. Okay, I like it. Yes. Ooh, much better. Well, that's really awesome. We can now see it a little bit better. I like it. We can actually see what's written on it. That's cool. Okay, good. We actually got it to what we wanted. I think FFF, it's a shorter. Can we do all? 1, 2, 3. Okay, so that's what you usually have with hexadecimal color codes. It should like that, and I think that's white. I always get white and black confused. One's FF, 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 6 Fs, and 1 0 0 0 0 0. Okay, that's even better. It might have actually made it. But that, I think, is looking way better right there. We can actually see what's going on. So we've done this right here. We've created everything we want right here. And I really want a title on this, though. It's probably one of the simplest things I want to do to fix this code up a little bit. Oh, and no, we'll worry about re-putting this in here in a moment. But the title is my biggest issue with this right now. Like, we don't have a title. So to add a title to a ggplot, what you would logically think here is before we get to P here at the end, we should be able to go to P plus GG title, because it's a ggplot, I would have thought, and just say hello, and then go here and do this. But it might get mad. It's already gotten mad a bunch of times today. Okay, it's mad. Non-numeric argument to binary operator. Okay, where is it mad? What's it mad about? It's a ggplot object, is it not? You should be able to add, is it geom title it wants today? I thought there was a geom title. No. Let me look up this error message. And let's see. I do not know. Adding a title should be so easy. It is a ggplot object, I would think. Let me... geom line interactive. We can do GG arrange. No, but that's going to be problematic. Let's try this. GG arrange. So we need to go to GG pubr. GG arrange. PP. Okay, let's try this. Just I want to see if this works. See if it can be GG arranged. Oh, it's mad. It's mad as per usual. Okay. Didn't like it. Didn't like it. Okay. So it's not liking the title. You would think would be one of the easiest things to get. But let me go to add title to geom point interactive. Add title to geom point interactive. Okay, wait. Someone's saying customize. Here it is. Plus theme. Okay, wait. Labs. We just need plus labs. Geom point interactive plus labs equals title. Okay, wait. There we go. Let's go plus labs. Okay, so why don't we store this into object graphic? No, we don't want that. Okay, so graphic. Cool. We got that stored. And then we'll go to graphic plus labs. And then title equals test. Yeah, it's mad. It's all kind of mad. Plus geom point. Let me look at this. Okay, I'm going to grab code right here and see what the code says to do. And let's take a look. MT cars data set, all this good stuff. And they're showing an example right here. They've got stored in the GG scatter. Okay, so there's their point. Mouse over points. Well, we can't do that right now. And I should be able to mouse over the points. So I don't understand. The code's not doing what it should say. And where does this end? Yeah, that's the end of the ggplot, and then you just do the labs on it. Labs, yeah, that's what I was doing. Just adding it to it. You know what we should do? Let's try this. Let's go to the start. What's going on, Gabriel? Good to see you here. I was making a funfetti plot. So here's my my plot so far in interactive plot. I've been updating this code and getting it to, it doesn't have to be funfetti if we don't want it to be funfetti. We could actually just make it UT orange. But if you have a question, let me know. We'll just bring it back to UT orange. But let me know, Gabriel, what you're working on. I'm talking about regression right here, and we're kind of making it. I want to add it so it figures out the residual. So that's one of the things I've been working on right here is I'm trying to make it so this code actually finds the residual for us, because right now it finds these values and equation paste. Oh, you see, there's the equation it's creating, because it actually shows you the equation right here if you click on this, which there we go. So we actually should have it take the y variable. So you see it's saying the x and the y, but it's not actually saying x and y. There it is right here. Equation, and we should be able to grab the name of the y variable right here. Like I could make it say height, but oh, that's if it's logistic, it looks like. You just woke up from your nap after class. Awesome. And you're like, wait a minute, what's he doing? I know it's like, there's the intercept, there's the digits. We should be able to take from the equation, there's the name of the y variable. We should be able to just pull that, and it should just be a name in the data set. New data equals, so we should have the summary output. I'm trying to see right here. New color. I'm trying to find where they get the point right here. Is there this form good enough for what we talked about in class today? Are there? Yeah, this is pretty decent. This one, the main issue with this plot, and I'll show you in a good way. Great question, 100 points. Thank you for asking. The main issue with this plot right now is actually the what. And we have another way of looking at this. I'm basically just trying to make a really cool code. So the main issue is there's going to be outliers, a lot of outliers, and also you can see it a little bit better here. What is another issue you see with this? What issue do you also see with this, Gabriel, right there? I also see an issue that the line, these are like additional polynomial orders we could look at. So I see another issue with it that the line might not be what, if you think about like the way the data goes through it. The line might not be what. Like the points rather with the line might not be what. And go here to 0033788. Cool, let's try that. There we go. The points and the line might not be what. Because I really want to show the residual. I want to say residual. What do you think about the points in the line? They might be what, not what. Row names. There it is. I think this is where it's being created. No. I would say it's not straight enough. I think there's an issue with it not being straight enough. Wait. No, that's not it. Yeah, not straight enough. Exactly. Great answers right there, Gabriel. I would say not straight enough is a bit of an issue. I cannot figure out where he's creating this. It looks to be in that tool type thing, which he's saying tool type equals tool type. And I keep saying A. The equation. I'm so close to figuring out where that's at. Like to where that's being stored, and then I can manipulate it. Because I just want to know where, and they're even pulling the name of the variable. It has to be in a paste. Facet name. Okay, wait. I'm so close. This is not it, is it? No. It has to be in a paste being created that way. Let's go look at those pastes. Paste 0. Okay. No, wait, that's a new line right there. That might be it. Oh, no, this is it. This is it. Here it is right here. We found it. Okay. Yeah, that residual right there. Great job, Gabriel. That residual right there is crazy high. And look at this. This is it where it's being created, because we see right here X name. You know what we could do? Watch this. This will be really nice. With the X name, they've already got X name and Y name created. So my question would be, when they're writing the equation of the line right here, why they don't just use so where did they put that? Watch this. We're going to fix this up and make this look a bit nicer right here. We're just having some fun right here. I love doing this kind of stuff. Here it is right here. Okay, so this is where they're writing the equation. I saw it a second ago. Paste right here. Good. Paste right here. This. Okay, so this needs to be y name times. So that needs to be in its own thing. And then we need to have here X name. Okay, so now, I don't know why they didn't do this, I mean, they've written all this code, but just ways to improve this. If I have done this correctly, cross your fingers. Oh, no, it didn't do it. What? That, I totally did it, I thought. How is that not? I changed it to the Y name and X name. Or was I just changing code? Oh, I thought that changed it. Okay, we'll try one last thing right here. Hey, Kristen, great to see you here. I had a great weekend, just relaxing, just doing some fun regression stuff. I'm just seeing if anyone has questions, and I'm just doing some regression here. But if you have questions, let me know. Always drop those questions in. Just be like, hey, can we do this question? I'm seeing if I can make this plot look amazing. And I'm gonna remove the data ID off it. I don't like the data ID. That's interesting. So. And that starts a new line right there. So that's got all regression. Oh yeah, regression all day long. So I'm removing that point ID number on it. There we go. We remove the point ID. I know, no, it's like that is today's lecture in 201 and 320. Tomorrow, where it's all about regression. All regression is that is already what regression does. Like this is a regression right here, and a regression will do what? I should have had those variables named. I swear those variables should have a name. All regression does is do a what with data. So what does regression do with data? So think about if we're going to do a regression on this data, it'll do a what? What will a regression do with data? That's a key thing to know. A regression is just going to do a what with data. So there's the regression, like here's the data, and then there's the regression right here highlighted in red. So what does a regression do? What does a regression do? And we're going to try to get it so we can find out that residual for us. Because, where were we at? Let me see what I was deleting at. I was deleting right here. Oh, it fits a line. No, don't worry, Kristen. Good answers right there. Don't worry. I don't know is a good answer. It puts a line through it. It does the y equals mx plus b, and it puts a line through the data. So regression is putting a line through data. And then the line explains the data. So we're going to write a line that goes through the data called the line of best fit. And so right here, we should be able to get, I see we got to get all the predicteds. Do we have a predicted data set? We should have a regression model. Let me do this. Let me go right here. Okay, there's the X name. And that's what X name is. That starts a new line. Okay, so you can see what this code is saying right here. For those, yes, Gabriel, perfect answer. So Gabriel, I know you don't code a lot, but take a look at this. Do you see where it says X name equals from the data set? This is going to find the X name right here. And that's the first thing you're seeing right there. X name is weight. And so that's the name of the X variable. And then it has equals 75. And then you're seeing the value of 75 where it says X name. This right here just starts a new line. So if we were to remove that, it wouldn't go to a new line. Like the reason you have that special character is you don't see it. It's just what creates a new line instead of it saying weight equals 75 and then immediately saying height equals 75. That \n stands for \new line or create new line. So it just says to the computer, create a new line. And I can show this by going here and saying, we'll just do a space. I like to keep everything looking the same. And saying \new line. And then we're going to go right here and say hello, or we'll name it hello. Hello. And I think we have it. Oh, we might need to grab something, grab an object. We'll just say yname again. We'll call yname again. And then we'll go equals. And then we're going to do 5 right here. So it's going to say it again. Like a new line, exactly. So if this worked properly, we should have started a new line right here. And now we're going to have equals 5. You see it says height equals 5. So let's go here to Brian. Oops. Let's go here to Brian. Okay, so we're just kind of manipulating this a little bit to make sure we get what we want. Whoops. I just reran the code. And now it should say Brian equals 5. There we go. Brian equals 5. So we got what we wanted. And I'm going to go and put some spaces here because I like spaces. And if you can tell, Oh, I didn't write all of this. I'm just manipulating a code someone else wrote. I wish I could write all of this. But you can learn a lot by practicing with someone else's code and getting it to look exactly the way you want it. If you notice right there, I'm just adding in extra things, knowing what the \n does, and kind of making their code look nicer. Like I put this all to one line. Like you could, the way people sometimes write their code is they might have it look like this right here. Like this will still run the same way because spaces are just kind of ran through. So it looks like hieroglyphs. Well, take a look. Does it kind of make sense if you look at it this way, that when you hover over this point, this is the first line of code where you're seeing weight equals to 75. So each of these commas separate out each argument. And then I put the next line of code, I put it to its own line to kind of logically show where it's going to show when we run this right here. And then this line of code right here, the Brian equals, is its own line of code right here where it says Brian equals 5. Now that doesn't change as we run the code because it's going to be, the same static value. What we want to find is we want to find the residual. This is the cool thing. This is where it comes back to Stat Tool 1 today. We want to find the residual, and that's going to be a tiny bit of a task for us. What we have to do is we have to add this to the data they're creating. They're creating data right here. Yeah, that's exactly it. Now it says residual right here because I changed that to where it says residual. So what you'd want to do is you want to get a prediction from the line. Now the line needs to save a predicted value, and this will be found in the data. So we need to look at where they're creating their data, and that's going to be at the very start. They're going to make a data set. Data equals fit of the model. Okay, so we can create our own fit model right here. Oh, you got this. It's so much fun. I love doing this. Let's go to M and go to model. And there it is right there. Okay, this might work. Test. We're going to call this test. And we're going to save the M I have with the model. So I'm basically creating an object like they created right here. Oh, it's got height and weight. Oh, man. So it's just a data frame. So typing X name and Y name applies to points instead of, because they've stored those. Good question. Hey, Adam, good to see you here. If you got questions, let me know. So they created an X name and a Y name. Good questions right there, Kirsten. So they created an X name and they created it. Let's look where they created it. I love all the questions. Can't tell I loved it. Here's where they created it right here. So they're storing into, actually, I don't even understand this. I don't know why you would store maybe they're just writing null into all these objects. That might be a quick way to store null, which is the nothing object. Null destroys something. It removes something from the environment. So they might be destroying all those objects that they already existed. But I've never seen someone do that. Do I need to use regression solver? Correct, Brent. Yep. Do you want to do one of those right here, Brent? Should we take a look at it? Because we got the homework coming up. We got time to do one. Let me know, Brent, if you have a question. So there's the fit of the model. Let me do this. Residuals equals. Oh, I think we got this. There's a regression. Yes, there is. Yeah, which one do you want to do? Tell me which one you want to do, and let's go take a look at that. Residuals and model. And you know what I think we just did? I think we solved it. Let's go take a look at one of those assignments. I think this will do it. I think this will. Please work, please work, please work. Yeah, which one do you want to do? Just name which one, and we'll take a look. And we might have just done my task. Nope. Model not found. Oh, wait. 2 seconds. Oh, it's the fit. Haha. Did we do the task I was looking to do? I'm stuck driving to Kentucky, Ohio right now. Not much going on. So, yeah, Gabriel, we got you busy right here. Just don't text and drive. We got you. We'll talk. We'll just keep you entertained right here, working on stuff. And look at that. We've now done it. One thing we want to do right here is we want to take and round that residual, but we've done it. We have updated this code. I need to save this. But where did I get the residual? To 2 digits. And so Kentucky. Love it right there. So check this out. We have now added to this plot right here. It'll show us the residual of each point. So every point, and take a look, The residuals of these points close to the line should have residuals close to what? So the residuals of those points close to the line, let's try to knit this here. But we've done it. We'll go here and do this. We'll delete the chunk, and then we'll add a chunk back in. And we'll put our include equals false. Show nothing but run code. Put that all right there. I had a lot of fun making this. Now we'll knit to HTML. Close to 0. Exactly, Gabriel. Exactly. You want to see the puppy? Oh my gosh. Now we go for... Oh, perfect. Perfect. 100 points, Gabriel, right there. 100 points. Check this out. We now have an interactive plot. We got the colors changed. We worked on changing the colors of this such that we could see the points. It interacts to the screen. You can put this in a web browser or whatever, but you can see the residual. You can see the weight of somebody, the height of somebody. You can also see the residual of somebody, but it calculates all these things for you and calculates the residual. As you can see, points close to the line have a residual close to 0. Points below the line have negative residuals. Points above the line have positive residuals. So all of this is being calculated for us. And that's what I like to tell people about statistics is it's not about solving one problem. Like when you do business analytics, it's about like, could I get this plot to show me every single residual? So I just have to know what a residual is. It's how much the model misses by, which is what we talked about today in class. But we're not going to go through here. Like when we're doing statistics, our goal with statistics will not be to calculate, these are the notes from today. Our goal with statistics will not be to calculate these residuals by hand, because we have code that finds every single residual for us. So I can tell you the residual of that point is negative 5.39, and I know that means that person's actual height is 5.39 inches below what they were predicted to be. So they are actually 70 inches tall. We could actually save their predicted value too. So watch this. How quick it was. Watch. I want you to see now that I know what to do right here. I'll put 2 minutes on the clock and watch this. You ready? We're going to go to the code we have, and we're going to go to the very start of it, where I made the residual. So where did I store that residual? Oh, wait, did I just hit the wrong button? I think I can do it in 2 minutes. Oh, there's residuals right here. I'm going to go to predicted, and I'm going to go to predict for it, the model, and we're going to round that. And then we're going to store and find right here the residuals. And we're going to take the same code, and we're just going to go right here. We're going to start a new line first because we need a new line of code. And so there's the new line. And then we're going to take the same exact code we have and say predicted equals predicted. And we've already got it stored. Now we're going to rerun our code. Is the line of best fit kind of like, it is actually the mean of all the points. Great answer right there. It is the mean of all the points. That is very true. So the line of best fit, ooh, we got a problem. We got a problem right here. There's a problem because it said you don't have a comma. The line of best fit is like, can the line and residual be related to the mean standard deviation? Kind of, sort of. The line is the mean of all the points at that observed value of x, or it's supposed to represent that, like theoretically. So the line is the mean of all the points, like it's the average value, if the line is properly going through the data. And take a look right here. We now have the predicted value. We could rearrange the orders of these to the actual and the predicted, but you can actually calculate the residual from this. And I just want you to think about, now that I understood how their code is working and I was able to find the things and calculate the things and add them, I was able to create a regression plot I want right here, which actually shows all the information. I still don't have my title, which would seem like the easiest thing to create to this, but I've tried 3 times to add a title. I'm sure I could figure it out, but this now has all the information, like this person right here, there's my 2 minutes. This person was predicted to be 6 foot tall, basically. They reported being 56 inches tall, which is 16 below. Look at the negative residual right there. They have a weight that's quite below what we predicted them to be. So all this great information right here, they're actually that tall. They weigh 218 pounds, but we have their X value right there. We could even add in a little bit things to make people understand those are X and their Y. I'm going to do one last thing. I am obsessed with this, if you can't tell. This is the X name, so I'm going to add the X right there, and this is the Y name, so we're going to add a Y right there, and then we're going to redo it so you can see. When you think about stuff like this is what I like to say business analytics is. It's not about solving this. It's about trying to help people understand this. And I like a space right there. Is that height in inches? It is, which is pretty interesting for some of the values, right? Some of the values really don't make sense. Did people know what they were reporting when they reported this? So, we want to think about how we communicate these results. And now it's a little bit obvious that my X is weight and my height is Y. And this will change with whatever someone enters in. It'll put whatever the X is, it'll name that X variable that, and it'll inform you that is the X variable. And then you have the residual and you have the predicted, which are related to the Y. We could even put residual Y hat or something like that. Putting the that's LaTeX or so to put the or CSS to do the Y hat, and that'll take me a moment. Some of the easiest tasks, like writing a Y hat, might be very hard to do, but the predicted would be the predicted Y hat. Excuse me, the residual's E, so we could add that in super quick. The Y hat, that is going to be the hardest thing for me to add. Residual is E. And so we're just adding notation right here next to it so someone could see that. I do not know how to get a Y hat on it. So there's the E right there. And so this is what's neat. Once you figure out the format, does it make sense, Kristen, that I'm just adding these little things? You can see what I'm editing in the code. And then over here, you can see how it appears next to it when I do say residual E. Now, these are different arguments. It interactively grabs the name of the variable such that if we have different variables right here, like if I change the variable someone's talking about to something like someone's GPA down here, like if I predict the GPA from somebody's weight, now when I rerun this model right here, the Y variable will be named GPA. And this is what's so cool about making code like this is now you can see right here, instead of it saying weight and height, it says weight and GPA. And that's because it's interactively taking the name of the Y variable. So whatever the name of the Y variable is will become the name of that Y variable there. Now it's always going to have that static Y on that because that's what we call a string. It's a word. Yeah, so no, I love this kind of stuff. This is what is fun to me, like creating this code, making these things that explain things and helping people understand. And we do have, it's driving me crazy that this does not have the names of the variables in it. I do not understand. Let's try one more shot at this. We're so close. I know, right? Let's find that star. Let's go back. We're trying to find, oh wait, here, round, that's not it. I love it. I absolutely love doing this kind of stuff. I want to find, okay, wait. Here it is right here. Here it is. Okay. Y name. Okay, so we're just adding in the Y name and the X name there instead of it saying Y equals. Does that make sense? Because the Y name is stored as Y name right now. This is R. Yep. And so who follows with me on this? Let's see if this works. I want to see if you follow this. I'll show you the first change. You ready? Instead of calling Y as a static object right there, a static string, I'm deleting that and I'm putting a new thing to start. Everything is separated by commas and calling Y name, which is where we've stored the name of the Y variable. Kirsten, does that make sense? That instead of saying a static like Y equals this, which is what happens when I hover over this, it says Y equals this. It's a static thing that's always the same. I'm then going to say, no, don't say Y equals. We're going to call the name of the Y variable we've stored, and that's a new thing. Like you have to separate each thing by a comma. So this is what it's going to look for. It's going to look for the name of the Y variable. And then I don't want it to call the X here. Instead, I'd like for it to call X name. And then we got to do a space. I'm adding in an extra space after that because I think that had a space. So I'm going to call in the space afterwards. We'll see if this works. Now we have it should say, yep, exactly. It should give the name of that for the name of the line. Let's see if it works. Fingers crossed. This is the way we code is we, yes! Now look at it. If you look at it right there, with one button, it actually says the names of the variable. So now we actually have it saying the names of the variable for the equation of the line. So that's awesome right there. And it's actually they put the, I don't like that. So they did it in the reverse order of what we usually do it. Well, that's not the end of the world. Where is it at? Y name equals, and there's the rounding. That's how they're rounding it right there. If X, let's put the Y name afterwards. Okay, wait, that's the Y name. Oh, no, that's correct. Okay, where's the intercept? Round slope. Okay, there it is right there. I'm about to do something crazy right here. Okay, we need this. That goes there. That's called bad idea. Yeah, we did, didn't we? That's driving me crazy. That is driving me crazy. I don't know why they would do that, and I don't usually do that. We don't do that here. Little tiny brown right there. We don't do that. I think I fixed it. Yeah, but it's a 0, I think. Where's the digits thing on it? Digits, round to digits. Round, intercept to digits, round slope to digits. So where are they? Are they just calling digits on that? Let me look. I'm gonna lose my spot. There we go. Digits equals 2. Okay, so now we should get significant digits to 2 on all of these rounded. Hopefully. And hopefully it'll do it in the right order. Okay, nothing crashed. I try to tell people you run. Why is it saying? Oh, it's saying the plus. We've broken it. I gotta go back. Okay, there we go. If else, if intercept is greater than or equal to 0. Okay, that's where it's choosing the positive or negative. Okay. Well, we could just take. There's the slope. Oh wait, there it is. No wait. Round. Let me do this. They got their code all crazy. There's the slope. There's the intercept. Okay, there's the slope. There's the intercept. Chapter 7. Yep. Yep. Okay, so now we have y name equals. Okay, that's the name of the y variable equals. Y name equals. There we go. Now it's so we can put notes here. We can say start of equation, and then we could say something like x variable. And this helps people to look at your notes. Like they didn't mark any notation, but I have to rearrange this now. So now we have it marked our y equals our x variable. Hey Brian, just wanted to ask away, Caleb. I'm working on functions right here. This is 474 related. We're gonna take this right here, and we need to go to right here and change the order of this. Then we don't need that. We're just trying to break stuff is what we're doing. Cool. Okay, and we don't need that padding at the end now. Okay, now let's give it a shot. Oops. I think I'm knitting HTML still. Let's see if it does the equation the way we want it. It's saying plus because I think it has to do that because it's positive. Okay, wait. So, and this is round slope to 2. Maybe it's such a small coefficient. Okay, so we probably need to, I think the coefficient is so small. Oh, need to go in here. I think the coefficient is so small, it's having a hard time seeing it. Digits equals 6. Okay, let's try this. I want to, because I don't like that it doesn't show it. And I have another change I'm going to make to this here in just a second, a quality of life change. Okay, that's good. It is showing it. It's just that it's so small. And the other quality of life change is where, oh my gosh, lost spot. No. Slope. Oh. Here it is. Did I lose it? Let's fit equation 2. Okay, wait. No, this is it. Oh, wait. Could you please go over brief exactly how clustering works and when we use it for it? Yeah, that's a big question here. 2 seconds, I'll check that out. Okay, we go here and do that. Okay, I think I have this how I want it. So clustering, talk briefly on that right here. So I think I finally got this the way I want it. After all that work, we now have the equation properly written. And let's go to the height weight. Stats 201, Donico, great to see you here. We're doing a whole bunch. We're going to talk about clustering here to end office hours. We're going to put 2 significant digits. We're going to predict someone's height. And then we're going to knit this and we're going to save it so I don't lose my work on this because this is a lot of fun right here. This is kind of me having some fun coding. Could you do one of the app features be as far as by comparing value? Yeah, you could. Yeah. That sounds like a good app feature. There we go. Why is weight not showing its coefficient? 2 seconds. I'm going to delete all that work I just did. Okay. Let's go check it out here. Let's go to the main screen. Okay. So when it comes to clustering, so this goes out to Caleb right here with clustering. Clustering is basically taking like-minded individuals and putting them together. What do we mean by that? Okay, so Caleb, I'd like for you to think about, like, these objects right here. I've got objects in my hand right here. I've got a Mega Man, I've got a phone, and I've got a coaster. Now the thing is you could say the Mega Man and the phone go together, because the Mega Man and the phone are both electronics. So you could be like, those like-minded things go together. Mega Man's an electronic. He's an electronic. The phone's an electronic. You could say Mega Man and the coaster go together because they're both primarily black, at least on one side right here. So clustering is finding similarities between stuff and then putting them together in groups. Does that make sense, Caleb? Like when you cluster things together, you're like, oh, this is like this, so it goes with this. But the problem is, what should we collect on? Now, here's the problem too. It's the curse of dimensionality, and that's a key thing you should know, Caleb, especially for your test for 474. The curse of dimensionality states that if we collect too many characteristics, everything starts to look different from each other. So think about this. If I ask people, are you born in Tennessee? You're going to get the people who are born in Tennessee and not born in Tennessee. Maybe we could cluster people on that. We could say, oh, these are the Tennesseans, these are the not Tennesseans. And then I say, well, were you born in Knoxville? And they say, and then you get the people born in Knoxville, not born in Knoxville. And I could say, well, did you go to school here? So we keep getting, have you experimented? I haven't done that one at all, Adam. That's a good question. So as you keep creating more subsections, everyone's going to start to look different from each other. If I ask everyone 50 questions, you know what's really interesting? Like 50 questions that are yes, no, and let's say they all have a 50% probability. What is the probability you would match with everyone on every single question that I ask? Just by random chance. Let's go look at that. So think about this. What's the probability if I ask you, do you like cheesecake? Let's say it's a 50-50 probability. If I ask you, do you like cheesecake, and it's a 50-50 probability, the probability of you matching with someone on that would be what, Caleb? So the probability of you matching on someone with, do you like cheesecake? Oh, nice. Oh, that's so cool. So if I ask, and Kristen says they do like cheesecake, 100 points for liking cheesecake right there. What would be the probability of liking cheesecake? I love cheesecake. So good. Cheesecake's amazing. So I'd say it's 50-50, right? Well, I mean, maybe it's a 80-20 or something like that. But it would be a 50% chance. And then we think about, and this is something we cover in 201, chapter 10, I believe. Or no, it's chapter 12, I think. This will be on test 2. What is the probability if I ask you, do you like steak? And the next one's 50-50. So the probability of somebody liking cheesecake and steak would be what? Like this is the probability of somebody liking cheesecake and steak is 50% times 50%, right? What's the probability of somebody liking cheesecake, steak, and let's say the Atlanta Braves or something like that? And we're just pretending they all have a native 50-50 probability. I ask you, do you like the Braves? What do you notice about these probabilities as I keep adding a new question that has a 50-50 probability? Every time I add another, let's pretend they're 50-50 because I know liking the Braves might not be 50-50, but every time I add a new thing, like to say, what's probably someone likes cheesecake, steak, the Braves, likes the beach over the mountains. Like I asked, do you like the beach or the mountains? And what's the probability you like this, 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 and this? What happens to the probability of somebody meeting all these criteria? Somebody meeting all these criteria of liking this and liking this and liking this and liking this and liking this keeps getting water each time I do this. So every time I'm doing this right here, the probability keeps getting water and water and water and water and water and water and water. It keeps getting what? What does the probability keep getting as we add another new thing on here to say, also, do you like musicals? It keeps getting what? Do you like South Park? Do you like Family Guy? Well, those might not be independent. It keeps getting smaller, right? Great answer right there, Shiv. So it keeps getting smaller and smaller and smaller. This is what the curse of dimensionality is. That if you keep collecting information on individuals and collecting more variables, everybody will start to think of a U word right here, because you're not going to really get groups if you collect like 100 variables on people and then try to create groups based on those 100 variables. Then it keeps getting smaller, right? So what's the probability of somebody being in the same group as you? If you collect 100 variables and you collect 100 things about people, what is the probability of somebody matching with you on all 100 things by random chance? The probability is actually that. Virtually impossible. 1 in like a quintillion, or not, this more than a quintillion. That is, maybe it's an octillion. Yeah, no, unlikely. Yeah, no, that's good right there. Good. A lot of U words, right? Great. Very unlikely, right? This is very improbable. Imagine you meet someone and they're like, I like cheesecake, I like steak. Well, those are things most people might like. But eventually, with 100 things, you might be like, well, that's really weird that everything is like this. I mean, either you found the perfect match or like it's really weird. There, as you say, saying there's a chance. Yes, I am. Mathematically, there's a chance, Caleb. But think about this. If you have like 5,000 people in a population, people are not going to match on a lot of the characteristics. So what we do when we do clustering is we try to find key characteristics. Like, let's say, like beach versus mountains is a very important factor to us. So we'd include that in one of our clustering characteristics. I think you might be working with like some delta data. So we might look at frequent flyer miles. And what you want to do is you think of clustering as a descriptive thing. Because if you have like a segment of your data that can be described as, let's say, people who, like college students. If you can make a college student section and you work for Kroger, would you maybe market to college students differently than you would market to 3 children households? Like if you have like 3 segments in your data, you have like older people. Not me. I'm in the college student age group because I'm still buying pizza rolls. You have the college student age group, the older people age group, and the family age group. So you've got 3 segments. Because my parents aren't really parents anymore. I mean, they're grandparents. They are still parents, but they're not in that parenting phase. So you've got like the parenting phase, the elderly phase, and you've got the young person phase, let's say. Those are the people you might segment your population to. Now, that's not the right answer. It's just an answer. Clustering is not about like knowing the answer. There are no answers. So Caleb, what do we call, and maybe you've heard this terminology, since there are no answers for clustering, there's no real answer. What do we call clustering? As we're searching and trying to understand, we're doing what kind of learning? I like to say the parents aren't home and we're just learning however we want. So what kind of learning are we doing, Caleb? If we don't have any real answers, there's no right answer to clustering. There's no right answers. There's no wrong answers. There's only better answers. The better answer is the one that helps us achieve our goal. So what kind of learning are we doing if we're doing clustering? And Kristen, it's another U word. No, wrong button. What kind of learning are we doing? It's another U word. So when your parents don't have a babysitter for you, you are what then? Seeing if I can jog Caleb's memory right there. So think about this, Kristen. I'm going to throw Kristen 500 points if you can get it. Caleb 200 points if you can get it. If your parents don't have a babysitter, think of the U word for what's going on. That's your U word itself. That's for the 100 points. So if your parents don't get you a babysitter, you would be what at that point? It's called this learning. Your parents don't get you a babysitter. Think of a U word. You are this. And we call it this kind of learning. Let's see if anyone can get it here. And then we're going to end off Sarah's here. We got class in 19 minutes. What kind of learning are you doing? Who knows? What kind of learning would it be? I attended. 200 points. I'll give some 200 points for unattended. Good guess right there. Good guess on the unattended. I'll give it another 10 seconds right here. We'll try to get those remaining 3. Boom! Oh my. Kirsten and Caleb, you're earning a full extra 500 points. Both Kristen, great job, and Caleb, good job too. Unsupervised learning. If we have something like R squared, which we actually covered today in class, we talked about R squared. R squared would be an instance of supervised learning. So because we can explain all the variation in data with R squared. That's supervised learning, but in clustering, there is no answer. So we say that it's unsupervised learning because there's no real answer to clustering, Caleb. Does that make sense? When you're doing clustering, you're just trying to find patterns in data and then put them into like-minded groups and saying, here's my young people, here's my elderly people, here's my young adults with kids, here's my young adults without kids. I'm going to send these people these coupons. I'm going to send these people these coupons. Then how do we measure the distances between the clusters? A few ways. One, we want to minimize the sums of squared error. And I think you probably have a few algorithms you're using, such as we can look at the simple the simple, right? Simple or complete, or you can do the simple, complete, the complete, the average, or the Ward's distance between clusters. You always measure between the smallest points, but the ways in which the clusters go together can be shown by a scree plot. I'm sure I'm using, it's the elbow plot. Do you know about the elbow plot, Caleb? We might have to come back here and talk about an elbow plot. But do you know about, I always tell my students this, I say bad elbow, good elbow, impossible elbow. Bad elbow, good elbow, impossible elbow. We practice that right there to understand how the elbow plot works. The elbow plot is the decrease to the sums of squared error, which actually relates to regression for quantitative variables. So there's quite a few ways to calculate the distances between points, whether we're doing it on the simple, the complete, or the Ward's distance, or the average distance. Haven't covered it yet. The elbow plot is going to show us, so let me pull up an elbow plot right here real quick, and then we'll end it. The sums, do you know when I say sums of squared error, what those are, Caleb? Like, tell me if I say anything you don't know. Elbow plot, k-means algorithm. So the elbow plot is going to help us understand how many, here it is right here. That's a good elbow. And they're using the, distortion. Never seen use distortion. Okay. So what the elbow plot is showing us right here, did they put distortion? Is the distortion, it looks like they're doing sums of squared error or so. Yes, sir. Awesome. So the sums of the squared error is basically the residuals. We were talking about residuals today. So the sums of the squared error is going to tell us how much we miss by. And so what you want to see right here is a very small sums of squared error. So the reason this is a good elbow plot is because you have a sharp decline. You want it to kind of go to a point where you'd say, I should use 3 or 4 clusters. That's what the k-means algorithm is telling us, that there was like 4 clusters or 3 clusters. And you kind of go to where it goes, but stops because it'll keep decreasing. If you put more clusters in your data, like more like cluster 1, cluster 2, cluster 3, cluster 4, cluster 5, cluster 6, you will always decrease the sums of squared error. But let's say we have 1,000 data points. How many clusters could we have, Caleb? Let me send the announcement for class while we're talking about this. If we have 1,000 data points, Caleb, how many clusters could you theoretically have? With 1,000 data points, how many clusters could you? Data we have is 1,000. So I'm missing the announcement. With 1,000 data points, how many clusters could we make? If we have 1,000 data points, we could theoretically make. That is a good elbow. So good elbows are the ones that go down. Someone thought we weren't going to have class because there was no announcement. No! No, be like, no. He just does that to be nice. He's a nice guy. Class in 15 minutes. So sorry about that. No, we have class every day. Every day. Unless something weird happens, unless something crazy happens. This is a very good elbow. Bad elbow plots don't have a sharp decline. And I'll explain that last concept. Good elbow plots look the following way. A good elbow plot has a decline that levels off. A bad elbow plot has a decline that never really has a point at which we'd say there's the elbow. You want to see the elbow. And then an impossible elbow plot would have the sums of squared error do what? Like, why is that the impossible elbow plot, which just cannot exist? Stats all day, every day. An impossible, so it's bad elbow, good elbow, impossible elbow. The impossible elbow plot, because we're talking about the sums of the squared error. So Caleb, conceptually, as we add more clusters, which is this way, these are the clusters being added. Conceptually, you can't increase the sums of squared error. You're welcome. I'm glad this helps a lot. This is just kind of some overview of the concepts. So conceptually, you want to see a point at which we have a good decrease, and it doesn't decrease much anymore in the sums of the squared error, which is basically residuals for 201. It's residuals squared and then summed together for a quantity of error. And the impossible elbow plot is impossible because sums of squared error can't increase. If we're putting more clusters, it'll help explain more. Exactly. So you can't have more error by putting more, like what we're doing visually right here, Kristen, is we're taking our data, and we've got data like this. And just tell me inherently, how many clusters does this look? Real quick, right? How many clusters look to be in this data? Like, this is the data we're working with. It's only got X, Y variables. So how many clusters look to be in this data? There look to be 3 clusters, right? And the more clusters, the better. But here's the thing. Right here is probably where we would see 3 clusters. Like, this is going to be where we see 3 clusters, because the decrease to the error is rather small. Like, you could add, if this is 100 data points, Caleb, how many clusters, if there's 100 data points here, how many clusters could you make? Because you could just keep, and you know what the sums of squared error would be if you add 100 clusters? So the answer is 100. If you add 100 clusters to this, the sums of the squared error would be 0. Oh my gosh, 0 error. But if you have 100 data points, you don't want 100 clusters. The point of clusters is to put things that are like-minded together, but you don't keep going till this graph goes to 0, because if you do add enough clusters, you could eventually get it to 0. Like, eventually that graph would hit 0, but 100 clusters isn't putting like-minded things together. It's putting everything in its own individual group. So at 100 points right here, you might have a sums of squared error of 0, but your goal is not to put everything in its own group. Your goal is to reduce the error and finding at what point you kind of see a good reduction. Does that make sense, Caleb? Theoretically, like, you could put everything into its own group and then there'd be no error. Because all the data points would be the clusters of themselves, and then they'd have no error from themselves exactly, because they'd be their own mean. Because in the k-means algorithm, each data point is going to be predicted by the mean of its cluster. So the error for this point over here, which is a residual, would be something like that point. Caleb, you're getting it. This is awesome. Caleb, an extra 100 points, right? Caleb, an extra 100 points. The data point right there would have an error of something like that. That point has an error there. So the distances, they are away, whether it be calculated with certain calculations, whether Manhattan or Euclidean, but it's just a distance calculation away. And then the way in which we cluster via dendrograms and stuff like that can depend on simple, complete, wards, or average. A lot of concepts, but we need to know the basics of what are we doing, why are we doing it, and that's got it. Well, we're going to head off right here. We'll be back here for class. That's the bar. I thought I had some stuff. I will see everyone a little bit here. Class in 10 minutes. Going to go grab some food. Be back soon. Bye for now, everyone. Bye. Great questions, Caleb. Great job, Kristen. Yep, Shiv, message me on Discord. We'll take a look, Shiv. You got it. Great work, Shiv, right there. Is there a function to get a rate of return for a stock? I had an idea of comparing. Well, let's take a look. That'd be really good to look at, Shiv. You bet. Message me and we'll take a look. See you in class, Kristen.